Okay, so SL paper 1, question 25. A model rocket is launched from rest. This tells us that U equals 0. The graph shows the variation with time t of the net force F applied on the rocket. The average mass is 0.2 kilograms. What is the maximum velocity reached by the rocket? So we know that Ft, by definition, is impulse. It's the change in momentum, which is equal to mv take u. If we have an object starting from rest, then u is 0, and therefore the area under the graph, which is Ft, will actually equal mv. So we're looking for the area under the graph to find mv, where m is the mass and v is the maximum final velocity reached. I can rearrange that and say that v, the final velocity, is equal to ft over m. Ft is the area under the graph. I've done that by separating into a triangle and a rectangle. So you can see that my area works out to be 15 because I've got a section that's 5 and a section that's 10. And I know the mass from the question is 0.2. So I've got 15 over a fifth, which is 75 meters per second. For 26, an insulated container of negligible mass contains a mass 2m of a liquid. A piece of a metal of mass m is dropped into the liquid. The temperature increases by 10 degrees Celsius, and the temperature of the metal decreases by 80 degrees Celsius in the same time. So delta T liquid is 10, delta T metal is minus 80. It asks for the ratio of the specific heat capacity of the liquid to the metal. We know that the metal must have started at a higher temperature because it gives energy to the liquid. So the Q gained by the liquid, the heat energy gained by the liquid, is equal to the Q lost by the metal, the heat lost by the metal. We know that MC delta T is Q. So we've got the mass of the metal multiplied by C of the metal multiplied by the temperature change of the metal must equal the mass of the liquid multiplied by C of the liquid multiplied by the temperature change of the liquid. I can rearrange that expression to find the ratio of C liquid to C metal, which is what we're asked for in the question. And then it's just substituting in the mass of the metal is m, the mass of the liquid is 2m. The temperature change of the metal is 80, the temperature change of the liquid is 10, gives me 80 over 20, gives me a value of 4. In question 27, a string is fixed at both ends so that we know that we have nodes at both ends. P and Q are two particles on a string, so we know that the amplitude of P is fluctuating over, the displacement of P is fluctuating over time and it has a maximum fixed amplitude. Q is also, its displacement is changing over time around another fixed amplitude value, but that's going to be smaller than that of P. The first harmonic standing wave is formed in the string. So the first harmonic is where we've got one node at each end only. What is correct about the motion of P and Q? Well, we know that this whole thing is oscillating with the same frequency, reaching different values of maximum amplitude everywhere along the string. However, the frequency oscillation is the same. In question 28, this is just a left-hand rule question. A current in a wire lies between the poles of a magnet. What is the direction of the electromagnetic force on the wire? So it's left-hand rule, first finger field pointing from north to south. My current is coming out of the page, if you visualize this in 3D, which means that my thumb points up, the force is up. That's your left-hand rule. Question 29. The center of the Earth and the Moon are at a distance d apart. There is a point x between them where their gravitational fields cancel out. The distance from the center of the Earth to x is d. The mass of the Earth is me and the mass of the Moon is mm. What is correct at x? Okay, so we know that the net value of field strength at x is 0 because they cancel out. And so the field strength from the Earth is equal and opposite to the field strength of the Moon. Field strength G is given by GM over R squared. So for the Earth, this becomes GME over, and the distance is D over D squared. For the Moon, it's GM of the Moon, GM with the subscript M, over its distance from X, which is d minus little d squared, which gets you to C. And then question 30, the unified atomic mass unit U is a non-SI unit to state atomic masses. What is it? This was just basic recall. You had to remember that U is 1/12 of the mass of a carbon-12 atom, and you just needed to remember that one for me.